All right, let's begin our next lesson, which is starting to put everything together and solving different formulas based on values that are given and isolating for variables that we need to solve for. All right, and so that's really the whole purpose of what we've learned so far in this unit, is to be able to, when the time comes, solve real-world applications, being able to rearrange formulas to solve for the variable we're looking for. All right, so formulas in mathematics, science, and business, we know that they can be represented often by polynomial functions. All right, we also learned in our first lesson of this unit that exponential functions are not a polynomial function, but we know that exponential functions is also often used to model real-world situations in science and business. All right, so formulas can be solved for an unknown simply by substituting known values directly into the formula and solving. Formulas can also be solved, so you can solve formulas by first putting in the values, simplifying it down a little, and then isolating for a variable. Or straight from the beginning, you can isolate for a variable before you even substitute any values. You can already rearrange the formula. Okay, so that's what we're saying here, is that formulas can also be solved by rearranging the formula first to solve for other variables in the formula that are not isolated. Let's begin with a simple interest question. All right, very simple formula here, I equals PRT, where I is the interest earned, P is the principal earned, R represents our annual interest rate, and T represents the time in years. Now, in our last unit, or actually our first unit where we did exponential functions, we used a different formula when we dealt with these scenarios, okay? In those cases, that was something called compound interest. This question is a simple interest question. Now, I'm not going to go into too much detail on the differences between simple interest and compound interest. I will tell you that compound interest earns interest more quickly. If you think about it, I just said that in our first unit, we dealt with compound interest, and in our first unit, we did exponential functions. So growing exponentially is better than growing in a linear fashion, which is what simple interest is. All right. So for these questions, it's a fairly straightforward formula of I equals PRT. Oh, and by the way, T represents time in years. So first up, calculate the simple interest when $2,500 is invested at 5% per year for 4 years. Okay, so let's write out first what's given to us. So we need to find simple interest, which is I. We were given P, what's known as the principal, which is the original amount invested. My R is 5% per year. Okay, so remember in our first unit, we did quarterly, monthly, semi-annually. This is simply per year. So our R value is very straightforward. It's just 0.05. We don't have to divide it by anything because it's just per year. Okay, and then our T is already in years for 4 years. And again, we don't have to multiply T by anything, okay, because this isn't something that happens more than once a year, right? It only happens 4 times in those 4 years. If it were semi-annually, it would happen 8 times in those 4 years. We'd have to account for that. But here we don't need to do that. So quite simply, this is about as easy as it gets. Multiply, or let's write out our formula. Let's multiply 2,500 times 0.05 times 4, and you get $500. Okay, so there's our simple interest earned. Calculate the annual interest rate when $2,000 is invested for 18 months and earns $125 interest. Okay, so initial investment, P, is 2,000. Simple interest, I, is 125. Okay, so now we're getting the left side of the equation. We're given a value for that. It says, what is the interest rate? So we're clearly going to have to solve for R. And time, I know you think might be 18, but what do we have to do to this 18? It's not 18 years, it's 18 months. So we have to convert 18 months into years. You may know off the top of your head that 18 months is 1.5 years. But how do you get that? Okay, what if it was a more complicated question where it was something like 22 months, for example? How would you convert that into years? Okay, here's what you do. You set up a proportion. If 1 year is 12 months, okay, then we can find out X amount of years for 18 months. So you set up this proportion and you line up years with each other, whether it's numerator or denominator, it doesn't matter, but they have to be lined up horizontally with each other and line up months with each other. So your units have to be lined up horizontally here, okay, in order for this to work. Okay, otherwise you're not setting up a proper proportion. And when you have a proportion equals another proportion with an X or with an unknown, we can cross multiply. So we get 18 times 1 equals 12x. 18 divided by 12 equals x, which is 1.5 on your calculator. Okay, so this is kind of even though we didn't really need it for this case, that's kind of the bulletproof way of doing conversions. I always tell my class, my students, to set up proportions and cross multiply. All right, let's solve for R. So here's our formula. Let's substitute in all our values. So 125 for I, 2,000 for principal. R I'll just keep as R, and then T is 1.5. Okay, well, I can multiply in any order. So I can actually multiply 2,000 times 1.5. Okay, so that's 125 is equal to 3,000 times R. Okay. Remove the 3,000 from the right, bring it to the left by dividing. So 125 divided by 3,000 is equal to R, and you get a decimal of 0.042. You want to carry those 3 places there, okay? Because our answer isn't just decimal 0.42. Multiply it by 100 to turn it into a percent. It's actually 4.2%. Right? And you want to have the 3 places here so that you can have a decimal place there. Okay, 4.2%. Okay, moving on. Now, we could have repeated this. We can repeat this question by rearranging the formula first. So basically solving for R before we substitute any values. And that's just as easy. So if we have I equals PRT, in order to isolate R, because it's P times R times T, we can divide P and T on the other side to move it over. So it becomes I divided by P times T is equal to R. So we could have done that to the formula to begin with without even substituting any values. And you may be liking this method more than the other. I feel like substituting the values in is easier. I mean, this was a straightforward formula, but formulas can get more complicated. And when you substitute in values, you'll find that you can simplify it a little bit to make it easier to solve for the variable. Whereas in this method, there's nothing to simplify. I mean, you just have to really know how to isolate for a variable, and you got to follow all the proper rules to do that. So I think it is a little bit easier to do the method we used in question B. If $1,000 was invested at 7.5% annual interest and earned $250 in interest. Choose a method to determine how long the money was invested for. So how long, meaning we're solving for t. Our principal or original amount was 1,000. Our rate is an annual rate of 0.075 take 7.5 divided by 100. And our capital I is 250. Very easily here, we can choose a method, it says, to solve. I'm going to go with substituting values in first and then solving for the variable. Okay. So first thing is, again, see, here's where we can simplify things down a little bit, right? Because we can multiply 1,000 times 0.075 before we even start rearranging this. So it's an easier rearrange. So this just ends up being 75 times t. And now this is a pretty easy equation to solve for t for. Okay, so t is equal to 250 divided by 75. Okay, and you end up getting 3.33 repeat. Now, I'm not a big fan of that answer, okay, just because 3.33 years is kind of hard to, I think we can turn the 0.33 into months. Now, I know that 0.333, I'm going to use common sense here. 0.333 is really just a third of a year. Okay, so when I think of a third of a year in months, I already know that this answer is going to be 3 years and 4 months because 4 months is 1/3 of a year. Okay? But there's a way to actually calculate that is take the 0.33. So if we know that, again, 1 year is 12 months, but we have 0.33 years, so how many months is that? Okay. X times 1, cross multiply. X times 1 is X. 12 times 0.33 repeated is 4 right on. So converting this into months, we got 3 years and 4 months. Or converting just the decimal part into months, just to give us a more clear understanding of how much time we have. Okay? And there you have it. Let's move on to our next example. Okay, so the formula V equals pi r squared times h, okay, is used to determine the volume V of a cylinder with radius r and height h. Determine the volume of the cylinder with radius 7 and height 10 to 1 decimal place. Okay, very straightforward. Okay, simply substitute in your values because you're just solving for V. It says determine the volume. Okay, our radius is 7 and our height is 10. Okay, and it says to 1 decimal place. So our final answer for volume is 1,538.6. Now, what's your units? It's a volume question. Volume deals in 3D, all right? So volume, it would be the units of centimeters cubed, okay? And if it was area, it would be squared. Area deals in 2D, right? Whereas volume deals in 3D. Okay, now this gets at least slightly more challenging for us. We need to find the height for a given volume and a radius of 5. So our volume is 1,000 meters cubed. Our radius is 5 meters. What's our height? Remember, it's for a cylinder, again. Okay. Now, you can actually multiply pi times 5 squared there, or pi times 25. I'm going to just write out another step here. I'll put the 25 there. You can actually, and try to use the pi button on your calculator so it's more accurate. Okay. So you end up getting 1,000 times, okay, approximately 78.5 times my height of h. Solve for h, and you end up getting, so 1,000 divided by 78.5, you end up getting 12.7 equals h. Now, what's your units? Meters. Okay, so it's given in the question already. It's meters. Okay, what if we isolated for h first? Okay, so if we had the formula v equals pi r squared h, very simply, because it's pi times r squared times h, bring this whole portion and divide it on the other side because it's multiplication on the right. So you end up getting v divided by pi r squared equals h. And you'd get the same answer. Okay, last example, it's going to be an exponential function here. Okay, so we're going to kind of use what we learned in the first unit. So I just want to remind you of two formulas that we looked at in the first unit. One was the initial value times 1 plus the growth rate to the power of x, while the other was 1 minus the decay rate to the power of x. So growth rate meaning situations where growth is occurring, decay rate you would use in situations where you're decaying. All right, so let's create an equation to model this data. Okay, now let's see here. I'm going to use proper letters, so I'll use P at N. Okay, or actually we can even use P at T, so time for years. Okay, is equal to, now do I know my initial value? Okay, do I know my initial value? I do not. I do not. So we end up getting, let's leave it as A. Okay, and then 1 plus the growth rate of 1.5, which is actually 0.015, to the power of t. Okay, so now what have they given us in the question? They have given us, obviously, the growth rate. I put in the growth rate. And actually, let's clean up this equation. Okay? And they've given us t, which is 10 years, right? They've given us that, which means that we can then solve for a. Okay, and actually, or have an equation that can potentially solve for a. So let's go up here. P at t is equal to, and actually we've already written it. I don't need to write it again. I've already written it there. So this is our answer here. Okay, so that means we can now sub in any values for a to figure out what we need here. Oh, and actually, I mean, I can substitute this 10 in, and let's do that actually. Okay, so let's actually do that here. So we have population, okay, okay. So if the current population is 12,500, what is the expected population 5 years from now? 5 years from now. Okay, so if our population, which is P at T, is 12,500, T is 5 years, okay. Sorry, if the current population, my bad there. That's our A value, right? That's our initial value. We're starting at 12,500. We want to know what it's going to be in 5 years. Okay, so let's go with P. Let's write out our formula. P at T is equal to A times 1.015 to the power of T. We're going to replace T with a 5 and A with 12,500. Okay, so really straightforward here, just like the stuff we did in Unit 1. So P at 5, so population after 5 years actually ends up being 13,466.05. But we know that you can't have 0.05 of a person. So just round this to 13,466 people. That's your final answer. Okay? And just know that you can rearrange for any of these variables in the equation. So like, for example, if I were to write out the original function, just as a side note, okay, we'd be able to solve for A, we'd be able to solve for the growth rate, okay, potentially, as long as we're given the other variables, like we're given X, for example, we're given A, we're given the left side here, we can solve for the growth rate. Okay, so let's look at quickly how to do that. So I'm just going to present a question and we'll solve for the growth rate here. And I'm just going to make up numbers. So let's say I have 1,000 on the left. I had an initial value of 100, let's say. Okay, but I did not know my growth rate, but I knew that my time for this was, let's say, 3. And it doesn't matter about the units. Okay, and actually let's use a nicer number. Let's use 2. Okay, how would we solve for the growth rate? Well, first thing that I would need to do is actually remove this 100 here before I can touch anything in that bracket of 1 plus growth rate squared. It's the first thing I move over. So I do 1,000 divided by 100. Rewrite the right side. So I end up getting 10 equals 1 plus the growth rate squared. Now you do what we did in our last lesson. Because we have squared here on this side, I can't do anything with the 1 plus GR yet until I remove the squared. So I square root on the other side. But I know that mathematically, because it's a 2, and this is square root, it can be the plus or minus version of that. Okay, so it could be the plus or minus version of the square root of 10. Now, in real life, there's a good chance that you won't use the negative value, right? But mathematically, we know that it exists. It exists. So if we take the square root of 10, okay, we should get something like plus or minus 3.2, let's round it, 1 plus GR. So notice we still have 1 plus GR. We have not solved for GR yet. Now, if we subtract 1, okay, we now will get our answer. And look what happens when we subtract 1. So we go -1 plus or minus 3.2, because remember, it could be -1 plus 3.2 if 3.2 is positive, or -1 minus 3.2, right? If our answer was negative. So we're actually going to get 2 answers here. One of them won't make sense. The other one will. So -1 plus 3.2 is equal to GR, but I'll put an or. -1 minus 3.2 is equal to GR as well. Mathematically, again, these exist. There's 2 answers here, okay? So here in this case, we would of course get 2.2 is my growth rate. Okay, versus -4.2. Okay, so 2.2% there. This one would obviously not make any sense. Okay, or sorry, not 2.2%. That's as a decimal. If we want to change that to a percent, we need to multiply that by 100. And so it's actually growing. This is actually growing by 220%. Sorry about that. So the value you get that comes out of that formula is the growth rate as a decimal. Don't be fooled because you see 2.2 that you think it's 2.2%. This is actually growing by 220%. All right? So there you have it.